Thank you very much. Thanks, ladies and gentlemen, for sitting in and listening to this talk. Some fairly dramatic news there, and I guess it reinforces what I'm going to talk about, and also what the previous talk was around, was the importance of non-Chinese supply of critical materials, especially as they relate to a sustainable future. So I'm talking about Rhyolite Ridge. Those of you who don't know the project, it's a lithium and boron deposit located in Nevada. It's the most advanced lithium development project in the United States. It's with a fully completed bankable feasibility study completed over a year ago. It's also one of only 2 lithium and boron deposits of any large size known globally. So it really is a world-class and globally significant lithium and boron project, 100% owned by Ioneer. Some important notices for you to read there. A quick corporate snapshot, which I'm not going to dwell on, other than to hit the high points that market cap of the company is around about $700 million. We have about $90 million in cash. Completed a financing recently with the aid of Goldman Sachs and Ord Minnett. So we're well positioned, well funded in that respect. A nice share price chart there, which if anyone sat in on Tim Hoff's talk yesterday from Canaccord, would recognise that, like many other lithium stocks, it follows both the Tesla share price and the price of lithium itself. Incredible sort of, fundamental change in attitude towards the lithium sector around about September, October last year, which coincided with the Tesla Battery Day. We've got an amazing and experienced board that I'm very fortunate to work with. I think we've probably pretty much got all aspects of this project covered with this board. 4 of our board members are based in the United States. One of our board members, James Callaway, the executive chairman, has been one of the few people that has actually built a new lithium project through to lithium chemicals type project anywhere in the world in the last decade, and is a great asset for the company. But in addition to that, we have significant boron experience with Alan Davies. We have engineering and project execution experience. We've got environmental and social governance experience on the board, and a really strong team ready to build this project, and obviously the management team there that works closely with myself. So just to touch on a couple of high points, general high points around the project. I've mentioned it's the most advanced lithium development project in the United States. It's a world-class asset by any definition of the term. Strong project economics confirmed by a bankable feasibility study completed by Fluor early last year. Importantly, it's resilient across a range of commodity prices, both of lithium and boron. The boron is not a byproduct, as some people might think. It's actually a co-product. It's about 30% of the revenue. It's expected to be the lowest cost lithium producer globally, and I'll show you some support for that claim. It's also a very large deposit. Currently the resource is about 146 million tonnes, sufficient for 25 plus years of production at the rate we're talking, but it could be a lot larger than that because it's open in several directions. It's in the right location. Again, the critical and strategic nature of assets of this type in Australia and in the United States is going to be increasingly important, I believe. We are well positioned to supply into the burgeoning electric vehicle industry in the United States, the second largest vehicle fleet in the world. A number of gigafactories are already either under construction, operating. There's more slated, so Rhyolite Ridge is well positioned to be a major supplier into that rapidly growing industry. Commitment to sustainability, that's something certainly that our board is adamant about. We're producing the raw materials that are necessary for a sustainable future, is one of the key drivers of the company. The critical mineral itself, lithium, required for electrification, static storage of power, is an important thing for obtaining us or reaching a sustainable future. But in addition, this project has some fundamental attributes that not too many other, if any other, lithium projects have, certainly not the combination of them. So it's very low water usage because the water is recycled. All of the evaporation is mechanical, so it's captured, condensed, reused. It's a very small footprint. There's no mine tailings, there's no tailings dams. It uses the power generated from a sulfuric acid plant to run it, so it does not use any grid power. It's not connected to, or won't be connected to the grid. The CO2-free power production. So all that energy, the power, the heat that's required for evaporation is all driven from power generated on that sulfuric acid plant. Some quick look at the economics of the project. I'm not going to run through all of these, you can read them for yourselves, but importantly, 22,000 tonnes of lithium carbonate or lithium hydroxide. We can produce either or both, and we start with carbonate, and over time we transition into hydroxide. 174,000 tonnes of boric acid. So, roughly over the 26 years of mine life, it's around about an average ratio of 1 tonne of lithium to 9 tonnes of boric acid. The revenue that would produce is about $422 million a year. 70% of that at sort of current lithium prices, about 70% of that revenue is from the lithium and 30% from the boric acid. So, $120 million a year from the boric acid. And that's really why this project is so attractive, is that contribution from that co-product and the combination of those two materials in the one deposit. So I mentioned we expect it to be at the very bottom of the cost curve, and obviously that's a bold statement to make when you're not yet in production. But nevertheless, we've completed a bankable feasibility. We've completed a full simulation pilot plant to support those both capex and opex numbers that then play into that position on the cost curve. But I want to sort of dig into that a little bit more with this next slide, which is a little bit complex, but I think once I explain it, hopefully you'll see, and if you've got questions, please come up and talk to us later. But I mentioned there's 1 tonne of lithium, 9 tonnes of boric acid, and it's the same process to extract and produce both. It's not a boric acid plant and a lithium plant. It's one plant. You leach the rock, the lithium and the boron come out together, and as you produce lithium as a final product, you make boric acid. It's part of the chemical process. So there is no cost for lithium and cost for boron in this deposit. You can arbitrarily assign costs to one or the other, but the reality is it costs us about $8,200 a tonne of lithium to produce that 1 tonne of lithium, 9 tonnes of boric acid. Now, 9 tonnes of boric acid, if you do like to think of it as a credit against the operating costs, represents about 70% of your operating costs. So the $8,200 after the boron component is taken into account brings your OPEX costs down to about $2,500 per tonne of lithium carbonate or lithium hydroxide, battery grade material. So incredibly low cost because of that contribution from both the commodities. Significant expansion potential. Again, I'm not going to dwell on this slide, but please come to the booth and have a look at the map. The deposit is a sedimentary type of deposit. So some people think of it as clays. This is not a clay. This is dominated by the mineral called silicitt, which is a sodium borosilicate. So it's sedimentary. It's flat lying to sort of gently dipping, about 20 metres thick over several square kilometres. That's what makes up the 146 million tonnes. But it's open, and you can see on the map there that all of our drilling is shown in the black dots, but the green is the outline of the old sedimentary basin. So this could easily be double or even possibly triple the size as we drill out the rest of that basin. And stage 1 quarry is shown there. We call it a quarry because it is akin to quarrying. It's a flat lying, 20 metre thick layer that outcrops and then just dips gently in towards the centre of the basin. It's ideally positioned to supply into this burgeoning market for this material in the United States. As of today, the US produces 5,000 tonnes of lithium chemicals per year. That's it. By 2024, it's estimated that the US will consume about 100,000 tonnes annually of lithium chemicals. And by some time depending on the rate of take-up of electric vehicles, which seems to be accelerating, but by some time between 2025 and 2030, the US will need somewhere around 300,000 to 400,000 tonnes of lithium chemicals. And remember, that's from today, 5,000 tonnes. And there's obviously an increasing importance being put on shortening the supply chain around lithium batteries so that is does not become a concern from a strategic point of view into the future. So domestic production is going to have to happen in the United States, and both the previous administration and now the Biden administration is committed to that. I think the Biden administration recently announced about $174 billion to be spent to stimulate the electrification of the transportation in the country. Those sort of numbers are amazing sort of numbers when you think we're going from nothing to 300,000 tonnes in the space of 4 or 5 years. That's the entire global production of lithium today. And if you listen to Tim Hoff's talk yesterday, he said that, and I agree with him, he said that Europe will need by 2024 300 to 350,000 tonnes. So that's the entire global production as of today. So you're talking about incredible growth in a commodity like we've never seen before. A little bit on sustainability and the environment. I've mentioned some of these before, so I'll be very quick with these, but low emission, that's because we're not using power from the grid. All the power is generated from this sulfuric acid plant, which has 0 CO2 emissions. The low water usage is because instead of using evaporation ponds like are used in the brine industry, all of our evaporation happens in evaporators and crystallizers, so like big kettles. So as we drive off the water, we capture the steam, we condense it and we reuse it. And that's not done in any lithium operation in the world today. But it's proven technology. This technology is not new that we're applying to this deposit. It's just a unique deposit that's going to be processed using proven and known commercial technology. The small footprint is because we don't have tailings dams. We minimise, and in fact over time, because of the flat-lying nature of the deposit, that allows for an early introduction of backfilling into the pit, the overburden. Efficient use of equipment. We've signed a deal with Caterpillar, and Caterpillar will be supplying all of the mobile equipment for this mine. They'll also be supplying up to $100 million in CAT finance for it. But interestingly and significantly for both ourselves and Caterpillar, this will be the first full greenfields, fully automated mining fleet, so autonomous vehicles supplied and maintained by Caterpillar. Quick look at the path forward from here. So I mentioned about a year ago we completed our bankable feasibility study with the help of a whole host of consultants, but in particular with Fluor, the large US engineering firm. We're in the second quarter, obviously, of 2021, so in the short term we're looking at our first lithium offtake over the next few weeks to sometime before the end of June. We've already have all of our boric acid under binding offtake agreements, so that's already all put away, but we deliberately held off doing any offtake on the lithium until now, and that was because of various reasons, including the low pricing environment that we'd seen in lithium during 2019, 2020. So obviously we're in a different sort of environment now, and we've got really strong interest in offtake. We'll see the first of those this quarter, and I think there'll be a couple of others to follow. We're continuing to work on the engineering, so our aim is to be, from an engineering perspective, shovel-ready by the third quarter of this year, and we're on target for that. And an important sort of, I guess, element of our solving of the financing to build this project, it's an $800 million project, is that we will be bringing in a strategic partner. Now, Goldman Sachs have been helping us run that process over the last 12 months since we finished the feasibility study, and we've said just very recently that we're in the final stages with a short list of interested parties. So we're pretty confident that we will land that, end of this quarter, I think it says on there, but sometime over the next 3 or 4 months anyway. So we're well positioned there. The permitting, we're also working very closely with Bureau of Land Management, US Fish and Wildlife Services, with the aim of having the project permitted towards the end of this year. It's a 2-year build, so we would be looking at first production in early 2024, which just happens to coincide with some fairly large tonnage increase. Well, obviously that's going to be gradual over a period of time, but it's certainly an ideal time to be bringing new production on in the United States. So I'll finish with this slide and mention that we're on track to be construction ready by the end of this year, both from an engineering perspective, but also financing perspective, offtake perspective, the permitting. We've done a very detailed bankable feasibility. We've run a full simulation pilot plant. We've really done a lot of technical work to demonstrate the economics of this rather unique mineral deposit, which we're fortunate enough to own. Environmental studies, 2 years, or over 2 years now of environmental baseline studies. They've all been completed and submitted to the BLM last year, so they're all's on track there. And the binding offtakes are obviously an important part of the business, and so you're going to see some news on that in the very short term. Thank you very much.